We're going to look at dividing our radicals. When we're dividing our radicals, what we're really doing is we're getting the root out of the denominator. Okay, now we refer to this process as rationalization. Okay, so what we do is we use this little trick to get the root out of the denominator. What happens is we multiply both the top and the bottom, or the numerator and the denominator, by the conjugate of the denominator. Okay. When we multiply by the conjugate on top and bottom, we're really just multiplying by 1, because if you have the same thing on top and bottom, it's multiplying by 1. And anything times by 1 is the anything. So we're not changing the value of it, we're just going to change how it looks. Okay. Now here, notice we have 2 over root 5. Okay. Now we do have the option when you have just a monomial to multiply by just the radical in the denominator. If you have a binomial, you have to change by the multiply by the conjugate. Okay, so you could choose to multiply by either root 5 on top and bottom, or you could choose to multiply by negative root 5 on top and bottom. Both will give you the same thing. Notice here, when we have negative divided by negative, it's really positive, so we're still multiplying by a positive one. I prefer for the ones that have a monomial to just multiply by the radical on top and bottom. So here, when we multiply, again, remember this is just 1. So I'm doing this thing times 1, which will be this thing. So we're not changing the value, we're just changing how it looks. So on top, we're going to multiply straight across. Remember, to multiply fractions, you do top times top over bottom times bottom. So this gives us 2 root 5 over the square root of 5 times 5. Now remember, root 5 times root 5 is just 5. This is the reason that we wanted to write it or multiply by the conjugate or by the radical on the bottom, so that we would undo the radical. So then we end up with 2 root 5 over 5. So notice this part is a rational number, right? This is kind of where we get the rationalization from. Okay. If we look at the next one, we have a couple options that we could do for this one. I could times by negative 2 root 10 over negative 2 root 10. I could also times by positive 2 root 10 over positive 2 root 10. But remember, we're really just trying to get rid of the root. So I also have this option to multiply by just root 10. To get rid of the root of the 10. Okay. You can multiply by the 2 root 10, and then what happens is that you'll just have to reduce it. So I'm going to show you times by root 10 and then times by the 2 root 10. So if we multiply by root 10 over root 10, again, root 10 over root 10 is just 1. So this thing times 1 is this thing. It'll just look different. So on top, we're going to do 3 times 1 is 3, and then the 5 times the 10 underneath. And then on the bottom, we're going to do 2 times and then 10 times 10. Well, we have a pair of 10s here, so the 10s will come out. So on the bottom, we have 2 times the 10, and then we have no more root anymore, which is the point of multiplying by the root of the denominator. On top, notice the 10 can break down to 5 and 2, so then we have a pair of 5s that can come out. So the 3's still out in front. The 5 gets moved out in front because it's a pair, and then we have that loner 2 that's still underneath. So then I just need to multiply on the top and the bottom. So then I get 15 root 2 over 20. Now I just need to check, can I reduce? Well, 15 and 20 can reduce by a factor of 5. 5 goes into 15 3 times, 5 goes into 20 4 times. I also could have noticed that here and said, hey, we've got this 5 can go into this 10, which goes into it 2 times. And then I'm looking, can I cancel anything else on top and bottom? I can't. These 2's are both on the bottom, so they can't reduce. So then I would do 3 times 1 root 2, which is 3 root 2, and 2 times 2, which is the 4. So our final answer is the 3 root 2 over 4. Okay. If we had done 3 root 5 over 2 root 10, and let's times by the actual conjugate, so negative 2 root 10 over negative 2 root 10. So on the top, we're going to do the 3 times the negative 2, which is negative 6, and then on the bottom, underneath the root is what I was trying to say, you have the 5 times the 10. In the denominator, we have the 2 times the negative 2, which is negative 4, and then in the root, we have 10 times 10 underneath, so 10 times 10. And again, we have a pair of 10s on the bottom, so the 10s will come out. So then we get on the bottom negative 4 times 10, And then on the top, again, we have where the 10 can break down to 5 and 2, so we have a pair of 5s. Okay, so then we get negative 6, oops, no, I guess it's fine. Negative 6 times by 5 root the 2, right? Which then gives us on top negative 30 root 2 over negative 40. Notice the negative will switch to be positive, which is why you could also multiply by just the positive amount of this. And then notice here I have a factor of 10. So this one we had a factor of 5, this one we have a factor of 10, which is 2 times the 5. That's because we multiplied by an extra 2 here. Okay, so it just gives you, if you multiply by the conjugate, it just gives you something more that you'll need to reduce. So 10 goes into this 3 times, 10 goes into this 4 times, negative divided by negative is positive, so we get 3 root 2 over 4. Again, same thing. There's a little more numbers to deal with here, which is why I prefer this option, because the numbers are smaller, there's a little bit less things to do. When we have this kind of a problem, and you have a binomial, you have to multiply by the conjugate. You can't just multiply by the root 3. Or the negative root 3. You have to multiply by 2 minus root 3. If you don't multiply by the conjugate, you won't get rid of your root in the denominator. So if we look at what we're multiplying on top, we're just going to do 3 times the 2, which gives us the 6, and then the 3 times the negative root 3, which is minus 3 root 3. This 3 was on the outside, this 3 was underneath, positive times negative gave us a negative. On the bottom, we're going to have the 2 times the 2, which gives us the 4. And then remember, this is 2 root 3, and this one is negative 2 root 3, which goes to nothing, right? So then I just need to write the root 3 times the negative root 3, which is negative 3. Or you can be thinking that it's the square root of 3 squared, and the squared undoes the square root. Or you can think that it's the square root of 3 times 3. Or if the root times the root, it's the same thing underneath, it gets rid of the root. All of those are fine ways to be thinking about it. You still need to do positive times negative to get to negative. So then we can simplify our denominator. So 6 minus 3 root 3. 4 minus 3 is 1, which means it's really just 6 minus 3 root 3. So then this is our final answer. Okay. Let's skip that next one and go to the bottom right, and then we'll go to the bottom left. Okay. So here, I have a monomial on the bottom, but a binomial on top. So I can choose to multiply by 5 root 6, or negative 5 root 6, or root 6, or negative root 6. So the smallest one of those is to multiply by root 6 and root 6. Again, because it's a monomial, I have that choice. So on top, when I multiply, we do 4 times the root 6. The 4 is on the outside, the 6 is on the inside. Then we do 3 root 10 times root 6, so we get 3 on the outside, and then underneath 10 times 6. All over, remember fractions are top times top over bottom times bottom. So on the bottom we have the negative 5 times 1, which is negative 5. And then we have the root 6 times root 6, which is just 6 times 6 underneath, or it will be just 6. So we end up with 4 root 6 plus 3 root 10 times 6 over negative 5 times 6. Well, I didn't break down this root, so this is 2 times 5, this is 2 times 3, so that means we have a pair of 2's that I can take out. So I'm going to go sideways that direction. So we get 4 root 6 plus 3 times 2, and then root 5 times 3, because the 5 and the 3 were left over. We can also break down the 6 and see that it's 2 and 3, so that's why I didn't do anything with that one. All over negative 30, so then this simplifies to 4 root 6 plus 6 root 15 over negative 30. Now, we can also look to see if the numbers in front of the roots on top and bottom have something in common. So I'm looking, do 4, 6, and 30 have something in common? Yeah, they all are divisible by 2. So if I divide each one by 2, 2 goes into that twice, 2 goes into that 3 times, 2 goes into that 15 times, and I keep it negative. So this would be 2 root 6 plus 3 root 15 over negative 15. Notice I didn't do anything with the parts that were under the root. Those stay exactly the same. Okay. I also, it's conventional to put the negative not in the denominator. So this negative in the denominator is a little abnormal. So what I'm going to do is I'm going to move it to the side or to the front. So 2 root 6 plus 3 root 15 over 15, and then notice my negative went here. I also have the option, I'm going to go up now, to distribute this negative so that we would have negative 2 root 6 plus 3 root 15 over 15. And then if I distribute that negative fully, we'll get negative 2 root 6 minus 3 root 15 over 15. Right? So there's a whole bunch of equivalent answers that you could have. This one is probably the most conventional. And then I would say probably this one is the next most conventional, and then this last one. Okay? So let's try one other thing where we have two binomials. So we've had a mix of monomials and binomials, but we've not done two binomials. Okay? So on this one, I need to multiply by the conjugate. I have to do the conjugate since the denominator is a binomial. So I'm going to times by negative 8 minus 4 root 15. Remember, the conjugate is only the opposite sign in the middle, so the negative 8 remains negative. Okay? Now you may set up your boxes off to the side, so you may want to do negative 2, 3 root 3, and negative 8 minus 4 root 15. And then you've got this is positive 16. The negative 8 times the 3 is negative 24. Keep the root. And then you do the negative 4 times the 2, which is negative 2, which is positive 8. Then keep the root. And then we multiply the negative 4 times the negative 4 times positive 3 is negative 12. And then the 15 times by the 3. Okay. So then here, notice if I break down 15 is just 3 and 5, so there's nothing to do here. If I break down this 15, that's 3 and 5, but I had this other 3, so there's a pair here. So then on top, that means that I will get 16 minus 24 root 3 plus 8 root 15, and then minus 12 times 3 root 5. So then that's really 16 minus 24 root 3 plus 8 root 15 minus 36 root 5. Right, so not anything that's super nice looking, but it's still a fine answer. So 16 minus 24 root 3 plus 8 root 15 minus 36 root 5 all over. And then we have to multiply the conjugate on the bottom. So negative 8 times negative 8 is positive 64. And then remember when we're doing our outside terms that this will undo the inside term, right? So this will be, let's see what this color. So negative 8 times negative 4 is positive 32 root 15. And then if we do the negative 8 times the 4 root 15, that gives us negative 32 root 15. So these two things go to nothing. Right? So then we're just multiplying our last ones, which are the 4 root 15 times the negative 4 root 15. So negative 4 times 4 is negative 16. Root 15 times root 15 is just 15. So then on the bottom, we really have 16 times 15, which is just 240. So we have 64 minus 240. So if we do 64 minus 240, that gives us negative 176. So now our problem is 16 minus 24 root 3 plus 8 root 15 minus 36 root 5 all over negative 176. And again, we have that negative in the denominator, which just means I can change all the signs of the things on top. So you could go through like we did on this process where you take the negative to the top and then you distribute it to everything. But you can also say it's just going to change the sign of everything on top. So negative 16 plus 24 root 3 minus 8 root 15 plus 36 root 5 all over 176. And that will give us how we divide.